Now's our chance to actually use Gaussian elimination to solve three simultaneous equations with three variables. So what we're going to do, first of all, we're going to turn this into an augmented matrix. So the first column is going to be the x's, the second column is going to be y's, the third column is going to be z's. We're going to put a marker to say that we're now into actual world numbers and close it. So there's 3 x's, 1 y, 2 z's equals 1. 2 x's, 1 y, 3 z's equals -2. 2 x's, 2 y's, 1 z equals -3. So now we have an augmented matrix. We can actually use Gaussian elimination to determine what the values are. So I've prepared one here earlier. This is our sample. So again, I'm going to use the notation. This is row A, this is row B, this is row C. So what I'm going to do, first one is I want to get a 1 on that there. The idea with Gaussian elimination is to have a 1 there, a 0, 1 there, a 0, 0, 1 there. And looking at this, I can see that there's a 3 there and a 2 there. So what I'm going to do is I'm going to subtract this row from that row. So I'm going to go A minus B. So I draw a new. So A minus B is going to be 3 minus 2 is 1. That's good. I want a 1. 1 minus 1 is 0. That's pretty cool. And 2 minus 3 is -1. Just have to be a little careful with negative numbers here. And 1 minus -2, that's the same as 1 plus 2, is going to be 3. I haven't actually changed that second row at all, so that's just going to be 2, 1, 3, minus 2, 2, 2, 1. Okay, with practice you can put multiple operations into one row. So the next thing I want to do is I want to get a 0 here. I actually want to get a 0 here and a 0 here. So I'm going to get this one here. I'm going to go row C. Remember, this is A, B, C, minus row A. Minus row B. So I'm not changing the top row. 1, 0, minus 1, 3. That stays the same. I'm not changing the second row. 2, 1, 3, minus 2. But this row C is going to be C, 2 minus 2 is 0. 2 minus 1 is 1. 1 minus 3 is -2. And minus 3 minus 2 is equal to -1, because remember minus is plus. Okay, so now I've got a 1 here. That's nice. I've got a 0 here. I'd like to get a 0 here. How could I do that? Well, what I'm going to do is I'm going to go row B. I see there's a 1 here. I'm going to subtract this row from this twice. Minus 2 times row A. So I can do this as 2 separate steps. I can just multiply that by 2, but it gets ugly. So let's do this again. I'm not actually touching the top row, so that's just 1, 0, minus 1, 3. B is going to be, second row, B is going to be 2 minus twice that. So 2 minus 2, 0. It's going to be 1 minus 2 times 0 is 1. 3 minus 2 times that. So 2 times that is -2. 3 minus -2 is 5. And then we get 2 minus 2 times 3 is -8. And again, we haven't touched this row here. So we're getting here. What's that? So now we've got a 1 here. That's cool. We've got a 0, 1. I now want to get a 0, 0, 1. And that will then allow me to start reading the answers. So what's the next thing going to be? Well, there's a 1 here. There's a 1 here. I want to get rid of this 1. I can either go this row minus this row, or this row minus that row. It doesn't really matter. Mathematically, it will give the same answer. So I'm going to go B minus C. So this is A, B, C. I'm not touching row 1, so 1, O, minus 1, 3. Not touching row 5, minus 8. But now I'm going B, this row minus this row. So this is 0 minus 0. 1 minus 1 is 0. 5 minus 2 is positive 7. And then last of all, what have we got? Negative 8 minus 1. So negative 8 plus 1, that's going to be negative 7. Just about done. So the last thing we're going to do here is we're going to go row C divided by 7. So let's see if we can do this. So this doesn't change. So this doesn't change. 1, O minus 1, 3. O, 1, 5, minus 8, 0, 0. And I divide that by 7. So 7 minus 1. And that allows me to work out the solution. So remember, these are simultaneous equations. This row here, C, tells us this is x's, yz, z, 1z is equal to minus 1. Row B, now we've got a value for z. B tells us 0 x's plus y plus 5z equals negative 8. And we can then just do the math on that. So negative 8. We know that z is equal to negative 1, so I can just substitute that in. Y plus 5 times negative 1 equals negative 8. Y minus 5 equals minus 8. So y equals, take that across, minus 3. And then the final bit is from equation A. We can tell that x plus negative y, negative z equals 3. We know what z is, so x plus or minus z. Z, the value of z is minus 1, minus 1, minus 1, plus minus 1 equals 2. So we can tell from this, sorry about that, just checking through the maths, plus minus, that was minus 1, take that across, that becomes x equals 3 minus 1, so x equals 2. Yeah. So what we can tell from this is in this equation, x equals 2, y equals negative 3, z equals minus 1. And we can check this out easy enough just by picking an equation. So 3, just picking that first equation, 3 times 2 plus negative 3 plus 2 times negative 1 equals 1. Is that true? So 6 minus 3 minus 2 equals 1, and that's true. So we can tell that this equation, we got the right values. Woohoo! We'll do another example in a second, but that's the basic process. We write the equations down in an augmented matrix C, and then we try and end up with this formation here where it goes 1, 1, 1. And then we can just feed the values into the equations to get the initial values out.